I want to go through part 2 of the lab on geologic time. So on the left here, I have the textbook pages that everybody gets, right? I'll reference those, and then just the worksheet from the book. So everyone needs to read the descriptions of these units that you see here under field notes. We reference fossils. What's important here, you're not seeing pictures of fossils, but what's important to note is the age of the fossils. So in this table at the bottom, you have the oldest, the Cambrian fossils, up to the youngest fossils in rock unit R from the Cenozoic. And knowing, the age of the fossils helps you put these rock units in order. So do pay attention to that. You're going to, for table 2, just put the letter of what the oldest rock unit is based on your interpretation to the youngest. We're not going to talk about faults or unconformities, but if you look at this here, this is of course a block diagram. This is the granite unit at the bottom. Typically, what you see in a geologic section is the oldest rocks on the bottom, and that's true. So just to get you started, G, granite is the oldest one. I want to point out for later on in the lab, there's unconformity here. You have some weathering before rock unit C is deposited on top of that granite. And just looking further up, we see these other rock units deposited above C and G. We also have this unit D, which is an igneous dike, an igneous rock that would have come through in this plane and cut these layers, so we know it's younger. So you're only going to be writing down the order of A, B, C, D, G, K, L, R, S, and V. And the 2 units that should be the same age would be these volcanic units. So when you determine, where they would be in that ranking of oldest to youngest, you can draw a line between those. All right. But this is going to take some investigation and studying by you. And you can always ask me questions. Isotopic ages. I want to get you started on this one too. So what we have total, starting out for the granite or the dike, we have 1,000 total atoms. And for the granite, every 500 million years, half of those atoms become daughter atoms. That would be the half-life. So for the first 500 million years, you would see 1,000 split down the center. You'd have 500 parent atoms and 500 daughter atoms. If 500 million years passes again, you have the 500 parent atoms that would be here split by half, and so then you would have 250 parent atoms left, and then you would add 250 to your daughter atoms. So that would then be 500 plus 250, which would equal 750 daughter atoms. And at that point, you'd have, 1,000 million years having passed. If you were to have another half-life pass, you say you have now 250 parent atoms. You split that in half, you have only 125 parent atoms remaining, and then you add 125 to 750, and you'd have 875 daughter atoms. So that would be where 3 half-lives have passed. I'm kind of giving you the answer here, right? Just to help you understand that. So 3 half-lives, you'd multiply 500 million years by 3, and that would be the age of the rock. Think about this process for the dike, where we have a half-life of 40 million years, and we start off with 1,000 atoms total. All right, table 4 is expanding on what you did to order your rocks and sediments from oldest to youngest. So you take that information, but now you're going to think about faults and the development of the nonconformity on granite, um, and erosion to form a narrow canyon. So you need to go back up here and work it out to see where those events kind of interrupted depositions of rocks or came after deposition of rocks. But my advice is to read as much of, these textbook pages that you can to find that order. And as always, you can contact me with any questions you have about it.